Welcome. In this video, we're going to be talking about different use cases for this hackathon. But as we all know, this hackathon entails of two tracks. Track 1, titled PlotSenseML. This track is for projects that integrate machine learning with PlotSenseAI. You build explainable machine learning workflows, visualizations, or tools. Track 2, titled PlotSenseDev. This track is for extending PlotSense, whereby building features upon it, improve its performance, or adding of documentations that pertains to PlotSense. As we all can see from my VS Code, we have 3 use cases, or rather 3 projects. Project 1, titled Machine Learning Explainability Demo. This project shows us 1, how to load and clean our data sets. 2, train a simple machine learning model using the render forest classification. 3, use PlotSenseAI to recommend and generate visualizations. And lastly, get AI-driven explanations of the results we visualized. First things first, we need to set up our environment, whereby installing the required packages and dependencies for this project. You all may wonder what this is quite different from the looks of the normal code editor or normal coding environment. That's because I'm using Jupyter Notebook. So when we run our cell, after inputting our command here, which is to install the packages, we run our cell or execute the cell. As you can see, I've already done that. That is why you are seeing requirement already satisfied, showing us that these packages are already installed from my end, but you are going to do that from your own end. Step 2 is to import the required dependencies or packages. As you all can see here, we imported PlotSense as PS. And also, while importing these packages, we also need to import their modules. And as we all know, PlotSense has 3 modules: the recommender module, the plotgen module, and the explainer module. Next step is to load our datasets. And this datasets was gotten from, this is a real data actually gotten from an open source website titled DUCR. This is where different data sets of different kinds. So this the data we are dealing with is titled breast cancer recurrence. So loading our data, this is the code to load our data. And when we execute our cell, we get this output. The next step is to clean our datasets. This is the code for cleaning our datasets. We execute our cell, we get the cleaned datasets. These are the columns by specifications. The Derek Malik, some is the age range from 30 to 29, 40 to 49, and so forth. The next step is to split our datasets. This is the code to splitting our datasets into an x-axis plane or into an horizontal plane. So this is the code to splitting our datasets. Then before we move to any next step, because we're utilizing PlotSenseAI in this project, we need to get our API key from Grok. Now, when you go through our when you go through the readme.md of this project, you will see how to get your own Grok API key. So when you get your Grok API key, input it into this column here, and you run this cell. Then the next step is to train simple ML model using the random forest classifier. So we have to train the model to get an accuracy, as you can see. And when we ran our cell, the model accuracy output was 1. The next step is to use PlotSense recommender module. This is how to use it. You may be wondering what this line of code is. This is suggestions. We're using the suggestion variable to get a recommender for the data frame being encoded, and we listed the number of plus times we are going to get for the recommendations. As you can see here, they were numbered ranging from 0, 1, 2, 3, 4. So actually indexes, there are 5. So this is actually called an index. You could see the output for the recommendations. The plot type, we have histogram, scatter, bar, box plots, heat map. But we are going with histogram. That is what we're going to treat next in our next step. So this next step, which is step 8, is generating our visualization. And as you can see here, give the plot variable equals to this figure of the plot gen with the data frame, giving us our index of 0, which is histogram. So when we run our cell, it gives us this output of our histogram. Finally, is to get our explanations to the visualization. This is the code for it. We run our explainer plots, printed the explanation for plot sets, and the explanations to our visualizations, or the explanations to the visualization of our data was given out to us. This is plain English. Moving to our second use case. This use case is a demo plugin for PlotSenseAI that shows how developers can extend PlotSenseAI with anomaly detection functionality. So we are implementing a simple Z-score based anomaly detector into PlotSense to provide visualizations of our results. As you can see here, this are the respective folders for it. So this is basically the code for this. This is where the plugin actually lives. This is the detection. This is the code written for detecting the anomaly or detecting the anomality. This is the code to preview our visualizations. So running this, come to our terminal. I think project 1 is still going on. This is shut down. Coming to our terminal, we CD into the second use case, CD project. CD project. So to actually test our anomaly plugin, we are going to run this command here. Python-l examples. So we are running. This is an example for it. Examples. So this is where we actually see our anomaly. So run it. So I found out what the issue was. The issue was because of the .py that was at the end of this command. Initially, normally, how it's supposed to be is that Python needs to recognize this as a module, not a file, because we didn't go through the conventional route of integrating or exporting Python packages properly. So when I run this command now, it gives us the output of the anomalies detected. You could see here 100 and 120 are the detected anomalies in this project. So it's asking us for our Grok API key to be able to give us the visualization, or for us to be able to visualize this data. So let me input my Graph API key. To see here, so this is it. This is, as you can see, this is the visualization of our data sets. That's it for use case 2. Moving on to our final use case for project 3. This project is an interactive Streamlit web app that uses PlotSenseAI to recommend and explain visualizations for our data sets. And the data we're going to be working with is a climate data for some cities in the United States. Going through our project 3, these are the descriptions of this project in Python. First step is loading our data. This is to show our sidebar controls and all that. To test this project, we need to run a command in our command line. So open up our terminal, cd project directory, run this command, python-m streamlit run app.py. We hit enter. As you can see, this is the message from our terminal. This is where this project, the URL where we can view this project on the web page. This is the URL to the web page, and this is the web page view. So for us to visualize our data, we need to input our Grok API key. So when you input your Grok API key, click on enter. Our data is going to be visualized here. So this is the recommendations for the climate data sets. So this is these are the variables. We have different climate changes. We have humidity, temperature, wind speed. Also for the cities in the United States, we have Chicago, New York, Phoenix, Houston, and Los Angeles. So this is the preview. You could see here, this is the visualization index as it is from the Jupyter notebook. You see here, these are the list of visualizations that are available to us. You can actually increase it here to 5. Then this feature here is to show our data, our raw data that we are actually visualizing. So when I click on it, you can see here, see first rows of Chicago data is preview, and these explanations is to explain our visualized data. As you can see here, that is all for this video. So in the next video, we're going to be talking about submission workflow, how you can submit your project. Thank you very much.